All right, so we are picking up with the second part of the personal pop quiz for chapter 4. And so we are given the following information that angle A is congruent to angle C. So we have angle A congruent to angle C. And then we also have that segment BC right here is parallel to segment AD. And when we look at that as a transversal coming through there, then we know that one of the things that we're going to be able to look at as we go to do our proof is using some alternate interior angles. And so what we actually want to show is that triangle ADB, so triangle ADB, so this triangle here is congruent to this triangle here, which is CBD. So that's what we're trying to prove. Okay, let's go and erase that so we can put some markings on there. And let's start with our given information. So we are given that angle A is congruent to angle C, and that is our given information. Okay, so I'm going to mark that off again since I erased it. And so here's angle A to angle C. Okay. If we continue on with our given information, I could really just go to the next part of the given information, because the fact that angle A is congruent to angle C doesn't lead me to a next statement. So if I go to the next given and say that segment BC is parallel to segment AD, that's going to be given information. But then what it's going to lead me to be able to see is that the angle here, which is angle CBD, so angle CBD is going to be congruent to angle ADB, which is here ADB. And that's because if we have parallel lines, then that implies that the alternate interior angles are congruent. So I now know that this angle here is congruent to this angle here. Okay, so I've used that from my given information. I already have one angle congruent, and then I have a second set congruent. If I look at what else can help me here, I hopefully see that they share this side. And so therefore I can say that segment BD is congruent to segment BD, and that is the reflexive property. If we look now at what we have here, we have a angle, we have a angle, and then we have a side. And so we are going to be able to say that triangle ADB is congruent to triangle CBD, and that is going to be by angle, angle, side. All right, if we go to look at the next proof here, what I like to try to do is, that is helpful for me to figure these out, is that if I think about what I have to prove for this to be true, okay, so if it is telling me that I need to prove or I need to show that segment NO is congruent to segment SB, then what I know is that that's probably going to be by corresponding parts of congruent triangles. And so that means that I'm going to have to prove two triangles congruent first before I say that. So if you go and look at the bottom here, this last step is left blank. And that last step, I'm betting, is going to be that that segment NO is congruent to segment SB. And that's going to have to be probably by corresponding parts of congruent triangles. Now, I'm writing that in there, but if I was doing this on my own, I might not write it in, but I would think that. And then I would go up to this step here and say, okay, yeah, absolutely, I need to be able to prove that these triangles are congruent. And so I know I'm looking for a side, 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 or an angle, angle, side. That's what I need to work towards. And so that kind of gives me some understanding as to where I need to go with this proof, okay? So if we look at this, we can do one of two things. You can either trace these out or you can rewrite them. But what we have here are some overlapping triangles that we're going to need to kind of separate so that we can see what we need to prove. Okay, so if we look at this, it first tells us angle N is congruent to angle S. So let's go ahead and mark that off, that we have angle N congruent to angle S, and that is given. Okay. We also have that triangle OUB is isosceles with the vertex angle U, and that is given to us. But let's see what we can use from that to help us before we separate these triangles out. So if we are told that triangle OUB is isosceles, triangle OUB is this triangle right here, OUB. So we're talking about this triangle, and this is, U is our vertex angle. Okay, so what that tells us is that this would have to be congruent to this. And so that could be our next step in our proof, to say that segment UO is congruent to segment UB. And that is going to just be by the definition of an isosceles triangle. Now, when we are going to prove, if we want to prove triangle NOB, and if we look at where that would be triangle NOB. If we look at the hint here, what triangle looks congruent to triangle NOB? If we look at that, the triangle that looks congruent to that, or the triangle that looks to have the same shape and size, would be the triangle that is triangle OBS. So if we think about what we already have here, we already were told that angle N is congruent to angle S. We've done that. We now are about to say a little bit about this triangle in the middle that we're given some information out of. And if we were just looking at these congruent sides, we should know the next thing that we look for are angles, And so what we're going to say is that angle 1 is congruent to angle 2. And our reason behind that is that if we have a triangle with a pair of congruent sides, then that implies that the triangle has base angles that are congruent. So if we look at where angle 1 and 2 are located, okay, that is angle 1 is right here at O. So this is our angle 1 right here. And then angle 2 is at B, so that is angle 2 here. And we've just said that those are congruent. So now I have this angle congruent to this angle. So I was given angle N congruent to angle S, and I now have angle 1 congruent to angle 2. And if we look at what happens here on this side right here, this is that side here and here. And so our next thing says that segment OB is congruent to segment BO, and that is reflexive. And so we have this to this. And so if we look at this, that will now give us enough information to say that triangle NOB is congruent to triangle SBO. And if we look at our reasoning, that was an angle, and a side. Once I get that angle, side, and I have those triangles congruent, I'm now ready to show segment NO is congruent to segment SB by corresponding parts of congruent triangles.